Hi, my name is Chen Yu, and in this video, I'll be talking about DFS, which stands for Depth First Search. And you may ask, what is depth? Well, think about you are going to school from your home, right? Maybe here is your home. Oh, sorry. Your home. And you may see, well, here is a snack shop. Do I go there? No. And I keep going, gas station maybe, and finally I arrive at school. So you do no backtracking and you just follow this path. This means depth first. And we may also have learned what is the concept of stack, right? In CS 24 or 32. So a stack is a LIFO structure, which means last in, first out. So let's move on to a graph. You can see here a graph has some nodes and some edges. You can see like here, this is the edge and this is the node. So we may ask, if we start from node A, like which nodes can we reach? So to solve this question, we build a stack. And the first thing we do is put A onto the stack. Let's see, here is the stack and A is put into it. And we look at the neighbors of A, which is B and C. So now, we mark A as visited. What can I do about it? Yeah, maybe mark it red. And A is now visited. And we move it from the stack and put B and C onto the stack. Well, notice that, well, let's define the right-hand side to be the top of the stack so that we now are looking at C. Let's see what neighbors does C have. It has D and E. So we pop C first. Though B is at the top now, we don't care about it. We just add D and E. Oh, I forgot to cross it out. Okay. So now the top is E, and let's find what neighbors does E have. Notice here that neighbors means like what we're finding, looking for neighbors means that unvisited nodes, right? So if there is a connection between, let's say, A and E, when we are at E, we don't prop A because A is already visited. So let's continue. E is at the top, we pop it out, mark it as visited, no unvisited neighbors, we move on. The top is D, pop it out, mark it as visited, and no unvisited neighbors of D as well. So what's at the top now is B. We finally arrive at B, though it has been added since the time we visited A at the start. Let's look at B, and there's no agency nodes for B that is now visited. So we mark B as visited. And now we have visited every node of this graph in a DFS fashion. And for this one, I will leave you to consider it. It's the same idea. And let's do a summary of what we do in DFS. So as we can see, we push the start node. For example, here A is the start node, let's say, and the pop a node visited, which means that you pop the node on the top of the stack and you visit its neighbors. That's what we mean by pop a node and visit it. And we push its unvisited neighbors. So unvisited here is really important. Otherwise, for example, you visited A, you visited B, and when you look at neighbors of B, A is also neighbor of B, right? But we don't need to visit it again. That is just redundant because it already have been visited. So unvisited here is very important. And we will flag every node with a visited, true or false. So if it is visited, you'll know that you don't have to prop it anymore. And so let's look at the code idea. Here is a pseudocode. we first mark the node as visited, then for each of its neighbors of the node, if neighbor not visited, then we DFS the neighbor. So at this step, you can see that this is kind of a recursion, right? You just go from here to here again, and that's how you visit the whole map. So let's think about it like this. What can we do with DFS? We can find what part of the graphs are connected, and we call this a connected component. For example, here is your home, right? Let's say you live in the Goleta, and from home you can go to school, and you can go to Target. And let's say from school you can go to airport. And we've done the path of this side of the home, let's say, and we've propped its depth. So let's go to the other side. We see that you can go from Target to Chevron, and that's this depth, and here are all the nodes you can go to from your home. And we see that there's other two nodes here, which is Shell and Donut Shop. They are connected to each other, but not the rest of the graph. So here is another connected component. We see that in this graph, we have two connected components. And in each connected component, you can go from any node to any other node. For example, you want to go from Target to school, you follow this path, but you cannot go from Target to Shell because they are not in the connected component, in the same connected component. Yeah, I think that's it. Thank you.